Sanborani Abafundi. Okay, so we are on page 113. We're getting towards the end of this book and we are simplifying algebraic expressions. Right, let's have a look at this first one. Let's first write it out without any extra signs. So 2z plus 6y. Adding a negative is the same as subtracting, and subtracting a positive is the same as subtracting. Okay, so let's see what, sorry, I've written 7x there. It's not 7x, it's 7z. Okay, pay careful attention. Don't do what I've just done. All right, now these two terms are like this one here and this one here. 2z minus 7z, negative 5z. And these two terms are like 6y minus 8y, negative 2y. Okay, after a while you won't need to underline the like terms, but for now we're still doing that. All right, these are all like, there's 3 e's adding together, plus another one, 4 e's. And then we've got an f and an f. I'm not underlining those, they're both the same, so 4e plus 2f. Okay, like and like. Negative 2c, I've double underlined those, and like, plus 5, and plus d. We can't add those because those are all unlike, those 3 terms. F times f times f times f times f. How many f's have we got multiplying? 1, 2, 3, 4, 5. What's the shorthand for 5 f's multiplying together? It's not 5f, that means 5 times f. It's f to the power of 5. F times f times f, 5 of them multiplying together. Let's look very carefully at this, because remember the order doesn't matter, but the where the powers are does. That there is like, now that one's, that we've got a square on the a. We've got to find other ones that have got squares on the a. Yeah, that one's got squares on the a. Those two are like, even though they're in different orders. Okay? Alright? Now, what about these two? That's got a b squared a, and this one's also got a b squared a. So, let's write our final answer. Let's write it in alphabetical order. So the green ones combine to 5 things, and negative 2 things gives us 3, and those are a squared b's. The purple ones, we've got negative 3 plus 4, that actually takes us to plus 1 ab squared. Do I need to write the 1? I don't need to write the 1. Is it wrong to write the 1? No, it's not wrong to write the 1. Okay, but it doesn't need to be there. Alright, this one, just be careful here because there's some adding and some multiplying, and we've got to do that multiplying first. G times G times G, that's G cubed. So at the front we've got G plus G. Then we've got a G cubed. And then we've got another G at the back. Okay, now which of these terms are like? In fact, these are like. But they're unlike with the G cubed. So let's combine the like ones. G plus G plus G, 3G, and G cubed. Okay, that's the final answer. Right, this one over here, that's like with that. Final answer, negative 2ab, that's those two like terms. Then we've got a plus 4b, which is not like to anything else, and a minus 3a, which is not like to anything else either. And there's our final answer. Okay, the next one. Let's go back and use some color again. 4 and plus 5, those are like. X, Y's and Y, X's, yeah, those are like, because remember 3 times 7 is 21, 27 times 3 is also 21. So it doesn't matter that the order is different. Okay, but that X on its own at the back there, that is not like with anything here. So what's our final answer going to be? Our final answer is going to be 5xy, I'm doing the yellow ones first, plus 4 and plus 5 is 9, plus x. All 3 of those terms are unlike now, and we can't do any more. All right, Okay, so notice there's more practice now. Okay, all right, but now we're going to do a little bit more with multiplication. Okay, and we're going to remind ourselves about exponents. Okay, so if we think about this, we're multiplying these things. We can multiply them in any order. So what we're going to do here, we're going to rewrite this. We're going to write the 4 times the 5 at the front. And then we're going to write our x to the 4. And then we're going to write our x cubed. And then we're going to write our y squareds. And then we're going to write our other y. So this is all exactly as we had it, right? But now let's have a look. Okay, 4 times 5 is just 20. Now what does x to the 4 mean? It means 4 x's multiplying together. And then we're going to multiply by another 3 x's. How many x's have we got multiplying all together? Actually, 7. So the shorthand for 7 x's multiplying together is 20x to the 7. And let's look at the y's. Y squared times y. Here there are 2 y's multiplying together, and then there's another one. So in fact there are 3 y's multiplied together, and that's our answer there. Now at the beginning of this term we started off with exponents, and what we learned is that when our bases are the same, we can add the exponents. So that 4 plus 3 makes that 7. This 2 and this y over here, I actually started writing it and then I thought, oh, we don't need to write it. But that y has actually got a little 1 on, which we don't need to write. Okay? But that 2 and that 1, they add together. Right. Okay, now we're mixing it all together because we're also going to involve our integers. Alright? So everything's coming together. Notice if you don't know what 2 times 5 is, this first question is going to be very difficult for you. Okay, but pause the video, try exercise 13 and then let it play. Okay, so let's do this kind of in 4 pieces, alright? Firstly, the sign. Will the answer be positive or negative if we're multiplying a negative thing by a negative thing? It will be positive. Do I need to write the positive? No, I don't. Then, how many x's are there over here multiplying together? There are 3. And how many are there over here multiplying together? There are 4. Altogether, I haven't worked out the number yet. 2 times 5, 10. All right. How many x's altogether? There are 3 there and 4 there, 7 x's. And the shortcut for writing x times x times x times x times x times x times x, 7 of them multiplied together is that. And how many y's are there altogether? Well, there are actually 7 y's as well. So 10x to the 7, y to the 7. I don't need to write that plus. So I could just write 10x to the 7, y to the 7. It's not wrong to write the plus, but it's not necessary. Okay, right. Let's think about this one. 3 times 6. Okay, that's 18. Now we've got a to the 4 times 1 more a. How many a's are there altogether multiplying? That's right, 5. A to the 5. B to the 5, B to the 4. How many b's are there altogether multiplying? There are 9. All right, and then c squared. And there's our final answer. Okay, now this one. And you might remember that when we raise a power to a power, that we multiply the powers. You might also remember that when we've got a product, both things get the power. Okay, these are all exponent laws that we did earlier in the term, but let's say we couldn't remember that. What we're going to say here is, what does it mean to square something? It means multiply it by itself. So we've got a squared b to the 5, all right, a squared b to the 5, times another a squared b to the 5. What does that come to? How many a's are there altogether multiplying here? That's right, there are 4 a's. How many b's are there altogether? There are 10 b's. Because the bases are the same, we add the exponents when we multiply. Does it make sense? It always makes sense. Okay, now, here, we could write this bracket out 3 times. But in fact, when we raise a power to a power, we end up multiplying. So in other words, this will be x, 5 times 3, 15, and 2 times 3, 6. x to the 15, y to the 6. Okay, now if you'd forgotten that exponent rule, it doesn't matter. I'm going to show you how we can do it by writing it out in full. When we cube something, it means multiply it by itself and then multiply it by itself again. So we've got x to the 5y squared times x to the 5y squared times one more x to the 5y squared. Okay, now let's bring all those x to the 5s together. So we've actually got x to the 5 times x to the 5 times x to the 5. And then we've got y squared, y squared, y squared. Okay, how many x's are there all together, multiplying together? They're actually 5 plus another 5 plus another 5. They are 15. The shortcut for that is x to the 15. How many y's are there all together? 2, 4, 6. Okay, right. So let's write a little note for ourselves here. When we multiply numbers with the same base, all right, the base is this bottom number here, the same base, that's the base. All right, we add their exponents. So we add their exponents. And remember, the exponents are the little numbers at the top. So we add their exponents. These are the exponents here. Okay. Right, so let's look at an example of that. Just see if you can write down what you think the answer to this is going to be. X to the 5, y to the 4, z to the 8, multiplied by x squared, y cubed, z. And remember that z is 1z. Z with a little 1 on. The 1's not there, it doesn't have to be shown. Okay. Final answer. How many x's altogether? Well, there are 5 over here and 2 over here. So 7 x's multiplying together. That's how we write that. How many y's? Well, there's 4 y's here and 3 y's there. 7 y's as well. How many z's? Well, there's 8 z's there and 1 z there. So 9 z's. Okay. When we raise a number with a power to a power, then we multiply their powers. And notice that we're using the word power, we're also using the word exponent. All right, so for example, x to the 4 raised to the power 5, that will be x to the 20. But again, it makes sense, because what does it mean for something to be to the power of 5? It actually means 5 of those things multiplying together. There's 2, there's 3, there's 4, there's 5. Okay, and what does x to the 4 mean? Well, it means 4 x's multiplying together. There they are, 4 x's. This one also means 4 x's multiplying together. This one also means 4 x's multiplying together. This one also means 4 x's multiplying together. And this last one also means 4 x's multiplying together. Okay, let's count how many x's we've got all together. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. What's the shortcut for writing 20 x's multiplying together? X to the 20. Does it make sense? It always makes sense. All right, we're going to ask you to practice exercise 14 before the next lesson, and we'll look forward to seeing you then. Bye now. Have a great day, everyone.